So last time we have discussed this holography technique little bit, okay, but today again we need to discuss in more detail, okay. So as I said in the last lecture that there are two main process, okay, one need to follow in the case of hologram technique. So the first one is this recording of hologram. Sometimes people are saying constructing of hologram, and the second process is reconstructing. Okay, so right now look at the first part, that is the constructing of hologram. Here now at this process, okay, or in this process, you need to create or you need to construct your hologram. Okay, so again let me explain it to the, let me annotate it. Okay, just 1 minute. Yeah, so now you see here is the laser beam. Okay, now this reason I am leaving for you people to find out why we are using the laser beam also. Of course, if you are interested, then you can go for the ordinary light source also, but there is a difference. Okay, so that difference you have to identify why we are preferring laser beam light source rather than ordinary light source. But no doubt you can use
Sir,
ordinary light source also.
Chromaticity.
Huh?
sir,
Yes, yes, it's a highly monochromatic light, basically, fine. But still, there are few more reasons are there. So that's why this time I will suggest you people to go through the book. Okay, so I will not give you the answer at this moment, but I just give you the hint that it is available in the book itself. So just go through that, and you will come to know like why this laser beam is preferable rather than ordinary light source. Okay, but it is not like कि resource में use ही नहीं कर सकता. I can use it, but again, you have to focus on the output which you are going to get from this. Okay, so that is what, so same is like optical pumping or something, pumping mechanism as we have seen. So you can use any pumping, but you cannot expect the same output which one particular pumping is giving for a one particular system. Okay, so that is what the thing, same way here also. So laser is using, there is a purpose for that, so you have to identify the clear message behind that, why we are using that. So just go through that little bit activity for you people. Okay, so laser beam I have used, and then you see this beam splitter. Okay, here it is. Now this task also I have given to you people to find out what happens after I just told you that after passing through the beam splitter, the signal splits into two part, whether the intensity remains same or intensity will half or what happens. So that
sir,
you people have to find out. Yeah.
I had read about it, and what I found was that 50% of the light is transmitted and 50% of it is reflected. So like what I concluded from that was that intensity would become half of the initial one.
Yeah, intensity, yes, intensity will become half, but there is other thing will remain same. Okay, so that is why we are using this laser beam light source. Okay, and we are splitting into two parts because rather, see, the purpose is very clear. To create a hologram we required the interference. Okay, so whenever we talk about the interference, okay, this is the main part I am discussing right now. So the main principle behind the hologram technique is interference pattern. Okay, so for interference you require two things. Okay, one, at least two waves you required, okay, so that it can interfere and create the constructive interference or destructive, depend on that. So the two waves we are knowing as object wave and reference wave. Okay, now there is another thing. What happens if I use, rather than beam splitter, I can use two different laser source. Okay, for one, for let's say object wave, one for the reference wave, but that will not solve the purpose, because anyway if you are going to use two different sources, then there may be some lagging. Okay, so that's why so to avoid this kind of problem, they have come up with the idea of beam splitter, so that signal will be one, laser source will be one, but they are splitting the signal into two parts from the one source itself. So there will be no like I mean, there will be no chance of overlapping or any other thing which you can think of. So it's preferable always one source, but this beam splitter will split into two part. Okay, so you like this, we are incidenting the light over here, and then after beam splitter, one signal is going towards this mirror, let's say mirror 1 you say, okay, and this you say mirror M2 or mirror M2, whatever you say, and the other will come down to this. Now remember, after reflecting from mirror 1, this light will come directly to this photographic plate where you have to record the hologram. Okay, I mean constructive part you have to record over here in this plate, and the other light which are coming from this beam splitter, it has to go through the mirror M2. Okay, and then after reflecting from this, it has to go towards object. Okay, and what happens after striking to the object, it will reflect again. So after reflecting from the object, it has to come again to the photographic plate. Now remember, as you see over here, these points you see over here, these points over here, so they are almost reaching at this moment. Okay, you see slightly little difference because this photographic plate is a tilted angle. Otherwise, their arrival time will be almost same. So you have to make this arrangement in such a manner that this light or from this what you say reference wave and this object wave both has to match at the same time or arrival at the same time. So then only the constructive interference will happen. And if that is the case, you are going to record your hologram in this. Okay, and you people have already seen the theoretical part, the mathematical part, in which we are claiming that if your waves itself has some phase component, some angle, then in the resultant output also they will have the phase component. So that is why we are recording in the photographic plate not only the intensity but as well as phase also we are recording, and that is why we are saying as a 3D photograph is captured on the hologram or the this photographic plate. Okay, and remember one thing, at the last time some people have asked why this light is, it seems from the diagram that these lights are interfering with each other somewhere in between also. Okay, they are overlapping or interfering in with each other, but remember this is a 2D diagram, that's why it seems like this, but actually if you look at to the real thing, that nothing, no I mean not a single part of light is going to interfere in between. Okay, so don't worry with that. So that's why I said this is the 2D picture. Okay, but if you look at the actual setup, it is not intersecting anywhere. Clear? So this is how everything is written, the same which I discussed right now, everything is written over here in this part, so you can always go through that. Okay, so this is the process in which you can construct the hologram. Okay, so very simple, just like you're creating an account, as I told you last time how to create an account. So उसके लिए आपने वही ये लेजर बीम सिलेक्ट किया, मतलब पहले तो आपने प्लेटफॉर्म ढूंढा जिसपे आपको ईमेल आईडी बनाना है, दैट्स इट. एंड देन कैसे करना है वो ऑल सच प्रोसेस आपने डिफाइन किया, मुझे नाम देना है, नंबर देना है, व्हाटएवर, एंड एक यूनिक आईडी आपको चूज करनी है, पासवर्ड देना है सपोज. तो वो यूनिक आईडी आप समझ लो कि वो रेफरेंस हो गया आपका. ओके, क्योंकि वो सबको पता भी होना चाहिए कि क्या आपने यूनिक आईडी रखा है, देन ओनली यू विल गेट द ईमेल्स. बट इंपॉर्टेंट थिंग इज दिस ऑब्जेक्ट वन, यानी कि वो जो पासवर्ड है आपका, तो वो पासवर्ड से अगर मैच होता है देन ओनली यू सी योर अकाउंट विल ओपन इट अप, अदरवाइज इट विल नॉट. So in very simple layman language you can understand the principle of this hologram. Now let me coming to the second process. Okay, so I hope this first is clear. Now this is the second process, reconstruct. So just like as I said, you have created the Gmail or email account, but now if you want to access after some time, like what happens if I received any email or not or something, or you may want to send some email to someone. So a variety of categories may be possible if you have created the email account. So the same thing, after creating, you see we need to reconstruct also. In what case we require to reconstruct, and what are the parameters we need to keep in mind while reconstructing the hologram. Okay, so just like in the account creation process, as I said, whatever the let's say domain you have selected for creating the email IDs, let's say Gmail or Yahoo or Rediff, whatever, then for login you need to go to the same site, okay, or same domain, then only you are able to log in. So same way, if I need to reconstruct the same thing, hologram, then I need to use the same. So you see the techniques by which one reproduce the image is termed as a reconstruct. यानी फिर से अगर आप reproduce कर पा रहे हो, so the technique we are saying is a reconstruct. Of course नाम से भी clear है. In the second process, this process, the hologram is illuminated by a wave called the reconstruction wave. So the same thing जो आपने reference wave consider किया था, now we are saying is the reconstruction wave, or you simply call it a reference wave again. There is no harm in that. And third one, so this wave in most cases is similar to the reference wave, as I said, right? Because just like your Gmail account, if you want to open your Gmail account after creating that, so again you have to go to the same site, or same scenario you have to use so that you can access it. So similarly, if I need to reconstruct also, so then I need to use the same reference wave, and that is why previously they have
Hello,
considered as the reconstruct wave. Yes.
sir, what is this need of to reconstruct a image, right? Because once we
Yeah,
are
yeah. I will come to that. I will come to that. That is why I said na. See, after creating the account, what is the need of accessing again? Because you want to see some data is there or not, or you want to send some email to someone, right? Or you want to change some settings, right? It is not like once you created the account and then you forget, etc. Sometimes you need to change the password after a certain time, right? So there is a variety of things you have to do. So that is why this purpose of after creating the hologram, why we are going for the reconstruct process, because if you want to change something, if you want to change your data, if you want to change some details, okay, or some pattern you are going to change everything, then you require this process. Are you getting that?
suppose we
The
have to
purpose.
manipulate height of the image. That is why, right?
Yeah. Suppose if you want to change some data, and suppose after a certain moment, if you know, if you want to change some details of your hologram, right? Then how you will do that? Either you start from scratch every time, okay, or it's better already you have created, so you modify it a little bit as per your requirement, and that's it. So that is why we are using this particular process also. Clear? So as I said, if you want to access or if you want to change anything in the system, then again you have to use the same reference wave. Okay, so previously they said reconstruction wave, but as I said, this is nothing but the reference wave only, because you see in the third line they have cleared in it is similar to the reference wave only, which you used for the recording for the hologram. Okay, and the fourth one, you see, when the hologram is illuminated by reconstruction, okay, various wave components emerge from the hologram, and one of which is object wave itself. So jab aap light, when you incident the reference wave, okay, and there are variety of angles, ओके, अलग अलग एंगल से अगर आप लाइट इंसिडेंट करोगे, सो सेवरल कंपोनेंट्स विल इमर्ज इट आउट. सो एक पर्टिकुलर केस ऐसा होगा जिसमें वो ऑब्जेक्ट से भी आपका जो एमिट हो रहा है वो भी आपको दिखाई देगा. सो इट ऑल डिपेंड्स ऑन द एंगल एट विच यू आर इंसिडेंटिंग द रेफरेंस वेव. ओके, सो डिफरेंट कलर समटाइम्स यू मे हैव सीन ऑल्सो. हम लोग नॉर्मली जो देखते हैं आपके पास, अगर आप उस पर देखोगे, सो अगर आप टिल्टेड करोगे, एंगल को मूव करोगे थोड़ा सा भी होलोग्राम का, so it will emit different colors. Okay, different components maybe also you may see. Sometimes it may see some picture, but the moment you tilt the angle you may see another picture. Okay, so there are several information which is stored in the hologram, one can see by looking at it. But while reconstructing, of course you need to go to the depth part, because that part is available only with the constructor who has created the hologram. But for normal public, they can easily identify by looking at some particular angle. Okay, if I make 30-degree angle, then I will see this image. If I move it 45-degree angle, then I may see another image. So just to identify whether that hologram is original or not, because that will provide you by the manufacturer. So that is what the purpose is. But in the case of reconstructing, again we'll come to the process. I will discuss it one more time, maybe on the next slide. So here is the process. Okay, here is the thing you see. Let me annotate for you people. This is the setup for the second process, reconstructing process. So you see again this laser beam we are using. Forget about this beam splitter. By mistake it is keeping over here, so you remove it out. So laser beam directly, because we don't require this beam splitter at this moment. Okay, so if you remove this out, so this laser beam is there. Directly you have to incident on the mirror. Okay, and after reflecting the mirror, you have to incident on this photographic plate. Okay, now important thing is your particular image is already stored in this photographic plate over here from the first process. So what we are doing is we are incidenting this reference wave or the light on this plate, and we are able to see the virtual image of the image which is stored at this photographic plate. Okay, so वो जो light होगा, जो incident होगा आप इसके hologram के ऊपर, that will reflect and come to your eye. You see here it is the observer. So after reflecting this photographic plate, you will see some signal. Okay, this observer is you only, and you will see this virtual image which is stored inside only. Okay, now look at here. This is the photographic plate. Inside it there is this real image जो आपने first process के through record किया था. In some certain depth you see it is not at only top, it is at certain depth. This particular real image is stored of real object. Okay, but now what you see in this particular second case, when you illuminate with this, you see the virtual image. Are you getting the idea? See, there are few characters you consider in this picture. One is the real object, second is the real image, and the third is the virtual image. Okay, now let me take you the another example, so this process is also clear to you. Now recently you may have seen the cricket match, right? India Australia is going on, or there are New Zealand Pakistan and so many, and recently T20 or all such of formats, right? They are playing recently. So you people may have seen many a times that what they are doing is they are displaying the picture of a particular cricketer. Okay, so you see that picture is in 3D. If you see carefully, that player which is many a times they are floating on the screen. Okay, sometimes on the cricket ground also they are floating that the big picture of the particular cricketer. So that's a 3D image. Okay, so how they have created this? इट इज नॉट लाइक कि भाई जब भी कोई प्लेयर अच्छा खेलता है सो मैं उसको बोलूँ कि भाई तू गेम जरा बीच में रोक दे, मुझे तेरी फोटो लेनी है और फिर मुझे उसको प्रोजेक्ट करना है, right? So it is not possible to bring that object every time. So what they have done is they have captured the image at a particular time, okay, of real object. So here in the first process, that cricketer will be the real object जिसका फोटो मुझे लेना है. I have stored the real image, 3D image in the hologram, and whenever I required, I will float it like this. So what we are seeing is, now whenever you see this kind of picture into the stadium or maybe on the top of the ground or something or on the TV screen, it is not like that real object is there. No, real image is there which is stored in the 3D format, and now that real image you are seeing, so that's why we are seeing is a virtual image, क्योंकि image का image आप देख रहे हो. Are you getting my point? You are not seeing the real object, you are seeing the image of the image. Okay, so that image
So here,
already has, yes.
so we don't need the real object over here, right?
Yes, exactly. That's what my point. And
So then
same I told.
we need only two components, a real image and virtual image, and not the real object.
करेक्ट, इसमें कहा मैंने लिखा है रियल ऑब्जेक्ट, देखो. लेकिन पहले वाले सी फर्स्ट टाइम व्हेन यू आर गोइंग टू क्रिएट द होलोग्राम, दैट टाइम यू रिक्वायर्ड द रियल ऑब्जेक्ट, okay,
Right.
without which you
Okay,
cannot
got it.
store the image. So once you recorded, then you don't require the real object. Now every time what you required is that real image which is stored in the 3D format. Okay, now you eliminate it and you will see the virtual image. That means whatever you are seeing, that is not the original image, you are seeing the image of the image, which we are seeing as a virtual image. That's why, because original image or real image is already stored in this hologram or holographic plate. Okay, so what you see, this observer, what is seeing this virtual image, that means image ka image, right? So that image to image we are seeing, and that's why we are saying is a virtual image. That's it. So this is the process. All such things they have covered over here. Just go through it whenever you get time. Okay, it is easily available in so many books, but I hope now the purpose is clear for this, the purpose of
Sir,
using this also. Yes.
the real image is a 2D object, yes?
No, it's a 3D image.
So
रिमेंबर वी आर वर्किंग ऑन द होलोग्राम. ओके, 2D इमेज अगर लेना होता तो वो तो मेरा जो फोटोग्राफिक प्लेट थी पहले वाली जो कैमरास में हम लोग यूज करते थे, दैट विल सर्व द पर्पस. बट हियर इट्स रिकॉर्डिंग 3D ऑब्जेक्ट है आपका, और 3D ही आपका इमेज है, रियल इमेज स्टोर हो रहा है उसके अंदर.
so how do they
सर 3D इसमें स्टोर है?
सर 3D है
एक एक करके वो लोग क्या बोल रहे हो?
सर.
सर 3D इमेज इसमें
हाँ, 3D इमेज
इसमें स्टोर्ड है होलोग्राम में.
यस.
तो सर इसमें बाहर क्यों बताया ऐसे, मतलब ये रेज ऐसा?
कहाँ पे बाहर? ये तो ये बताया, ये 3D इमेज जो स्टोर्ड है ऑलरेडी, राइट? वो मुझे कब दिखेगा? सपोज कोई आप होलोग्राम लो, उसके अंदर कोई ऑब्जेक्ट या कोई इमेज आपने देखी होगी कई बार, राइट? या कोई लोगो देखा होगा या कोई इमेज देखा होगा. तो क्या किया, पहले वो ऑब्जेक्ट को रख के उसका फोटो ले लिया, रिकॉर्ड कर लिया. अब उसको अगर आप देखना है तो आप क्या करोगे, उस पर लाइट इंसिडेंट करोगे, मतलब आप देखोगे, राइट? देन ओनली यू सी. सो जो आप देख रहे हो ना, वो वर्चुअल, आई मीन जो वो रियल ऑब्जेक्ट नहीं है, ना ही वो रियल इमेज. जो आप देख रहे हैं वो आपको इमेज का इमेज दिख रहा है. So that's what we are saying is a virtual image. तो ये आपको केवल इंडिकेट करने के लिए बताया कि आपको वर्चुअल इमेज दिखेगा इस टाइप से.
सर मतलब ये पहले से ही रियल इमेज स्टोर है, तो इधर प्रोड्यूस क्यों लिखा है नीचे? वो जो आपने पैराग्राफ लिखा है उसमें लिखा है हॉलोग्राम, द रिकंस्ट्रक्शन वेव आफ्टर पासिंग थ्रू द हॉलोग्राम प्रोड्यूसेस अ रियल एंड वर्चुअल इमेज. रियल तो पहले से ही स्टोर्ड है.
करेक्ट है. मैं क्या बोल रहा हूँ, जो उसने पहले लाइन थी, एक मिनट, जस्ट मिनट, लेट मी गो टू द प्रीवियस स्लाइड. एक मिनट. You see this one, let me clear it out, this all such stuff. Now you see, मैंने क्या बोला, one particular wave, you look at the last statement. Let me annotate. You look at this last statement. So when you eliminate, okay, by that reconstructing wave, so you see various wave components will emerge out. तो उसमें possibility कि एक आपका जो wave itself है वो भी आपका emerge हो जाए. So that is what they are saying. अगर वो image होता है, क्योंकि see hologram is having all such details, every small details it is going to record, and that is why there is one more property which I need to discuss at the last, but anyway we can discuss it now. That if even at many people are claiming that since we know the purpose of hologram, that it is highly secure, I mean it is for the authentication purpose. So if someone has suppose stolen your hologram, for example, okay, एंड कट सीक में मान लो या जैसे भी है उसको आपको सक्सेस नहीं होने देना है, वट एवर बी द रीजन, सो ही हैव स्टोलन देयर होलोग्राम. ओके, एंड नाउ इफ दैट द होलोग्राम ही व्हाट यू से टीयर इट इन सो मेनी पार्ट्स, कई सारे टुकड़े में तोड़ दिया, राइट, फाड़ दिया उसको. सो व्हाट हैपेंस इज, इवन इफ यू गेट वन सिंगल picture or one single object also, one single, I mean, paper of that particular hologram, then also you can construct the everything, because that hologram store all such details even in a single part also. So if you are able to get, yeah, if you are able to get one single component also, okay, then you can create everything from that. So that is the importance of hologram, कि उसको अगर आप चुरा भी लो लेकिन आपके पास एक सिंगल भी डेटा है, थोड़ा सा भी अगर वो पार्ट आपको मिल जाता है टीयर वाला, उससे आप पूरा का पूरा डिजाइन फिर से बना सकते हो. सो दैट प्रॉपर्टी इट हैज होलोग्राम. ओके, इज इट क्लियर नाउ?
Yes, sir.
Okay, okay. So let me clear it out. So I was talking about this one. Okay, so I hope this is clear. The purpose is clear. Okay, and what we are seeing is, for normal public is seeing is image of the image. Okay, not the real object they are seeing. Real object is already captured by someone and they have removed now. उसका कोई रोल ही नहीं है, अब उसको प्रोसेस को बार बार यूज में ही नहीं लेना है. यानी कि आप समझ लो, कंस्ट्रक्टिंग का प्रोसेस एक बार होगा लेकिन रिकंस्ट्रक्ट का प्रोसेस आपको बार बार करना है अगर आपको देखना है, इफ यू आर ए ऑब्जर्वर. हाँ, लेकिन अगर आप क्रिएटर भी हो तो भी आपको ये प्रोसेस को फॉलो अप करना है, ताकि अगर कुछ चेंजेस करना हो आपको, देन यू कैन डू दैट. बट आप एज ए एंड यूजर हो, देन ऑल्सो दिस रिकंस्ट्रक्ट प्रोसेस विल बी देयर, बिकॉज आप क्रिएट तो कर नहीं पाओगे, है ना, क्योंकि या तो क्रिएट करोगे तो खुद का नया बन जाएगा, तो आप क्रिएट नहीं कर पाओगे कंपनी का. तो आप जो करते हो वो देखने का काम करते हो. सो बेसिकली यू आर फॉलोइंग द सेकंड प्रोसेस. दैट्स व्हाई आई सेड दिस प्रोसेस इज इन टू फॉर्म, टू स्टेप्स. Anyway,
Sir,
so now come to the, yes,
sir, exactly how did we convert it 2D into 3D? I did not get what.
that is what I said na. That's why I have given the mathematical example of mathematical proof also. The idea is very clear. Okay, if you have the wave, object wave, reference wave, if they are having phase component also, okay, so at the resultant, at the interference, constructive or destructive, so they will have the phase component also along with the amplitude. So let me go through the formula. If you are not clear, then here you see. So right now this is the object wave. Let me explain it to you one more time, those who are not able to understand. This is your object wave, this is the amplitude part, and this is your phase component along with that. Similarly, this is the reference wave, this is the amplitude, and this is your phase component. And that is why if phase component is already we are recording in, or we are storing in the object wave as well as reference wave we are considering, okay, then in the resultant also we are getting this amplitude and phase component, which you see on this next slide. Here you see intensity, I mean this amplitude square, here again amplitude square, but here in the third and fourth term you see this term. Let me annotate. So this is your amplitude, this is also amplitude, but this particular term will be amplitude and component. Here also in the fourth term amplitude and phase component. So this is the proof that you are not in the hologram, you are not recording only the intensity, but you are recording the phase component also. Why? Because in the object and reference wave also this phase component is there. But what in the earlier case, in the case of 2D, when this hologram was not there, let me come to that picture also so it will be clear to you. Fine. So let's talk about before hologram. So you skip this part. This particular term will not be there. Okay. This object wave will be there, no doubt, and this amplitude part will be there. There is nothing like this phase component. Similarly, this reference wave also, there will be no this component, only this amplitude part is there. Now if this is the case, object wave, reference wave, and now if you find out the same thing, okay, intensity, etc., which we have calculated like this. Let me come to the next slide. You see, so in this also, let me annotate. So you remove this term, या मैं इसको clear ही कर देता हूँ, then you see. So suppose in the earlier case, in the object wave, reference wave, I didn't consider this phase component. Okay, so in the resultant you will not have this. Okay, so that will be the sum of O naught plus A. That means amplitude only. Now if you take this intensity, Okay, again the same formula. If you open it up, okay, even though if you take this u, as I said, mod of u u square will be u into u star. That means star represents the complex and conjugate of this quantity u. So even though if you take the complex conjugate of this parameter, okay, mod of u square you do, so you see there is no I component, so only this component. So even this u star and u will be the same value, so that's why you will get only these two term. This third and fourth term will not be there. Okay, of course 2 times this will be there, 2 times o a or something will be there, but this phase component will not be there. So the purpose I am saying is, if you are not including the phase component in the beginning, then how can you expect the same in the output? Are you getting my point? And that is
Yes,
why
sir.
I have given you in the first slide very clear idea that normal photograph is recording only the intensity part. When I say intensity, that means they are recording only the amplitude along x and y axis. So that's what they have recording amplitude part. अगर phase include ही नहीं किया, so phase आपके output में आना भी नहीं है. तो hologram ने क्या किया? Hologram के अंदर we are recording intensity as well as phase component, and that's why we are getting at the output also. It's very simple. Now it is
Sir,
clear.
how did we record a phase in hologram? Can you explain with that slide? The
That is why I said,
constructors.
yeah, that is why I said, na, arrival time you see. Just 1 minute, let me go through that. Yeah, here you see. So this wave, or this reference wave, okay, this object wave, you see the arrival time. Okay, what is the, how do you define this interference? Constructive hoga ki destructive hoga? How you will define?
Depends on the
They are,
part difference.
Phase.
yes,
So
yes, part difference, phase difference. So here you see in this case, can you find any part difference or phase difference over here? It's
yes.
almost zero. So almost zero.
Yes.
Are you getting? The moment
Yes,
if
sir.
there is a change, of course that angle will be different, and chances are there that may lead to the destructive interference also. And that is why I said, if you want very clear picture, then this arrival time has to be the same. Then only you will get the clarity in your picture. If there is a mismatch, you may get the blur image also. And but if there is no matching, there is no, I mean, their arrival time is not matching, okay, then you will not see any image. You will see the blank screen or black screen. Why? Because in that case destructive interference will happen, क्योंकि वो मैच हो ही नहीं रहे आपके waves, यानी कि कंस्ट्रक्टिव कुछ है ही नहीं, तो आप कुछ रिकॉर्ड कर ही नहीं पाओगे. एंड दैट्स व्हाई वन कैन से क्लियरली कि भाई क्या हो रहा है आपके पिक्चर के अंदर.
Okay.
इज इट क्लियर नाउ?
And sir, yes, sir. And for this, the object shouldn't be steady. It would be moving around. मतलब rotate.
नो, ऑब्जेक्ट को आपको जैसे रिकॉर्ड करना है ना, उसको वैसे ही रखना पड़ेगा. सपोज मुझे अगर अगेन आप आपका ही केस ले लो, मुझे आपका होलोग्राम बनाना है, आपकी इमेज लेना है, राइट? तो अगर मैं आपको बार बार रोटेट करूं तो क्या होगा? मेरा इमेज भी वैसा आएगा और प्लस क्लैरिटी नहीं आ पाएगी. तो मुझे क्या करना है? मुझे ऑब्जेक्ट को फिक्स ही रखना है. या तो मैं आपको टिल्ट कर दूं, सपोज मुझे आपको वर्टिकल ना लेके हॉरिजॉन्टल पे आपकी इमेज लेनी है, तो मैं ऑब्जेक्ट को हॉरिजॉन्टल रखूं, यानी मैं आपको बोलूं कि आप हॉरिजॉन्टली हो, एंड देन आई विल रिकॉर्ड योर इमेज. क्योंकि आप मूव करते जाओगे साथ साथ, then it will not create the, because this arrival time will differ in that case. So that is why object has to be fixed for a particular time.
Sir,
Yes.
then only the image of the front side will be come. The back side will be not come. And for a 3D image,
Yes. So that is why in this picture you seems like कि ये 2D के हिसाब से आपको लग रहा है कि ये front side से ही आ रहा है. Okay. So if you look at the setup properly, okay, and that time you see this particular light we are incidenting throughout this object. वो 360 पे पूरा लाइट में इंसिडेंट कर रहा हूँ, तो उसी हिसाब से मुझे उसका रेफरेंस वे भी उसी हिसाब से सेट करना पड़ेगा. सो इट इज नॉट लाइक कि मैं ऑब्जेक्ट को घुमा रहा हूँ, समझ रहे हो? उस पे मैं पूरा 360 डिग्री के एंगल से लाइट को इंसिडेंट कर रहा हूँ ताकि वो उसका कैप्चर कर ले इमेज, रादर देन रोटेटिंग. अगर मैं रोटेट करूंगा तो पर्पस सॉल्व नहीं होगा.
okay, sir. Understood.
Are you getting that? This picture is 2D, that's why you may face some difficulty to understand, and that is why I am giving so many examples to understand what is exactly happening in this.
Yes, sir.
Clear? Okay, so I hope you will never forget this hologram concept in your life.
Yes, sir.
Okay. So this process we have covered carefully. Now coming to the important picture again, type of coherence. Okay. Slightly we are moving little bit in depth part. Okay. And it may also be possible that it may not be covered in the syllabus. I mean, it may not be the part of the syllabus, but it is important to discuss since we are discussing the hologram over here. Okay. So this is very important if you want to understand completely about the hologram part. Okay. So let me go through quickly. I will not take much time, but this is the important part which I think you people must know. So that's why I'm going to cover this. So you look at the types of coherence. So there are two types of coherence. One is we are knowing as temporal coherence. Okay. And how to differentiate between, as I said, there are two types of coherence. So how to differentiate between them? So the one is temporal coherence. And when I gone through the particular part, okay, all such temporal coherence and another type of coherence, lateral coherence, we are saying another one. So in that, what I found the difference is this. So it's very easy for me to remember. This temporal coherence is depending on the time. Okay. And many times people are confusing, like how I will remember the temporal will depend on the time, or maybe a lateral coherence will depend on the time. So I come up with a very simple logic. I have looked at this T at the beginning. Here T is also. So I consider as a TT. Okay. So that means temporal coherence here. That means it is temperature dependent. Another one is the lateral coherence. Later on we'll discuss in the next slide. Okay. Lateral coherence part. So that lateral coherence depends on the length or path difference basically. So I remember with this LL. So it's very simple for me to keep in mind, like which parameter or which particular coherence depends on which factor, because this is very important, right? If you're not understanding how this coherence pattern will depend on which parameter, then it's very difficult to understand the scenario of this hologram part. Okay, so let me come to the directly this temporal coherence. That means it is, I consider as a time dependent. Okay, it is not written in the book directly, but as I feel this particular coherence depends on the time, so that's why I have written purposefully over here as a time dependent. If you go through the book, I don't think so ki you will get these things, time dependent or independent something. But anyway, and what is the example of this temporal coherence? You see, to understand the concept of temporal coherence, we consider a Michelson interferometer arrangement. So I hope you people may have gone through this particular setup somewhere in 11th or 12th in the theory part. Michelson interferometer. पढ़ा है कभी?
No.
No, okay. So maybe recently they have skipped from the syllabus, but actually this is a very good experiment, slightly little bit different. So this Michelson basically he used an arrangement. Okay, he prepared an arrangement in which he has calculated the speed of light. Okay, so you just find out Michelson experiment about the speed of light on the internet. Okay, and you see, so the on what do you say, the basis on which we are claiming that the speed of light is something, right? 3 into 10 to 8 meter per second. Now what is the basis of that? So Michelson has given that experiment. Okay, he has provided that arrangement to measure the speed of light perfectly. 3.3 into 10 to 8 or something, whatever you have idea. Okay, meter per second. So it's a good experiment. I suggest you people to go through it once. Okay, so you just type on the Google Michelson experiment about the speed of light, and you will see all such related details with that. Okay, so it's very simple. And so all such things, source, etc., that setup. Okay, so it's to simply, if I explain, it is just like your formula, speed equal to distance over time. I think this formula you have gone through many times. Okay, speed equal to distance over time. Have you gone through this?
Yes.
Right, now let me explain it. The same formula is applies over here. So you see this tau. Okay, this is time duration. ओके, सो ये टाइम जो है आपका, वो आपने यहाँ पे इस पर्टिकुलर केस के लिए, कोहेरेंस के लिए, वो आपने टाउ से, टी की बजाय टाउ से रिप्रेजेंट कर दिया, नथिंग एल्स. स्पीड मतलब कि स्पीड ऑफ लाइट, तो वो यहाँ पे सी से रिप्रेजेंट किया, यू सी. ओके, एंड इफ यू टेक द प्रोडक्ट एज यू सी, अगर मैं टाइम और ये स्पीड दोनों का प्रोडक्ट ले लूं तो मुझे क्या मिल जाएगा? डिस्टेंस. डिस्टेंस, राइट? सो दिस डिस्टेंस इज नथिंग बट द लेंथ that we are knowing as a coherence length. So the formula is very clear now. Suppose if you want to find the coherence length of a particular source, then this is the formula, same formula which we are knowing earlier also, but here we have just modified the form, that's it. Same formula, speed equal to distance over time. Time मैंने यहाँ पे tau से represent किया है, okay, that we are saying as a coherence time because everything is coherence. So coherence time, same way c जो है आपका speed of light है, so this d, that means distance, is nothing but the coherence length, that's it. So coherence length will be this speed into time, that's it. Okay, so this is very simple. That format is slightly we have changed, nothing else. Now come to the next part. Here is the setup. Something similar setup you will see for the speed of light also. Okay, this source is, okay, and then again you see this this part, splitter, splitting the signal into two parts, this mirror m1 m2, okay, and again you see the arrival time. You see incident splitting into two part, okay, one is going here, second will be going here, and after reflecting again it will come down, come to the same at this place. After reflecting, when they come, they will create the interference at this pattern, at this plate, okay, and it will be seen by the person who is seeing this, okay. Eyepiece basically here, so anyone who want to see, they can see the output of the constructive interference.
Sir,
Your screen is not changing.
Oh, screen, where you are exactly?
okay, sir, now the screen showed the figure. Till now it was not showing the figure.
Okay, तो पता नहीं, it may be some network problem. Anyway, so let me explain it one more time. Okay, so what I was saying is, you see the source is over here, light is incidenting, here is the beam splitter, split into two part, one is going to this mirror m1, another is going to mirror m2. After reflecting this, you see, अगर आप perpendicular light incident करोगे तो उसी वे में वापस reflect होके आएगी, so it will reflect again like this, here also like this, and they are matching at this place again, and they will create the कंस्ट्रक्टिव और डिस्ट्रक्टिव इंटरफेरेंस डिपेंड्स ऑन देयर अराइवल टाइम. अगर वो अराइवल टाइम परफेक्ट हुआ बराबर, जितने टाइम में वो दोनों साइड से वापस आ रही है, इट विल क्रिएट द कंस्ट्रक्टिव इंटरफेरेंस ओवर हियर, एंड फाइनल आउटपुट जो कंस्ट्रक्टिव इंटरफेरेंस से बनेगा, दैट यू कैन सी थ्रू दिस आईपीस. क्लियर? So this is how the setup. I'm not going into much detail because it's slightly away from the syllabus part, but to give you the idea what is temporal coherence, where it is using, so that's why I have given this example. Okay, so remember, temporal coherence is there in Michelson interferometer experiment. Now come to the next. All such things I have given over here. Okay, so I will not see, but remember, as I said, the moment you change the alignment little bit, or maybe the arrival time of these waves coming from mirror 1, mirror m2 is different, then your output may be differ. Okay, so that's why you see this output. Let me highlight it one more time. You see this slowly moved away from G वो जो center part है, then you see कॉन्ट्रास्ट मिलेगा आपको फ्रिज में, डिक्रीज होती जाएगी, और जब डिफरेंस ज्यादा हो जाएगा आपका, लेट से कितना डिफरेंस, इवन दो द डिफरेंस इज just like few millimeters to few centimeter, even if this much small interval is also there, difference is there, you see the fringes are no longer available. So you see the accuracy, right? Even if the difference is only few millimeters or few centimeters, you will not see anything. Okay, so that is why this is a highly accurate experiment, and because of that only Michelson has able to find out the speed of light. Okay, slightly different setup will be there, but it is interesting. You people must go through that. Okay, because many times we are claiming the speed of light, so you must know from where we are getting this number. Now coming to the second type of coherence, that is the spatial or maybe the lateral coherence people are saying. Okay, so this particular thing you see, basically not, as I said, length, but rather than length, it mainly depend on the angle. So time and angle you keep in mind. Okay, so instead of length, either you keep in form of length also, or but it better to keep in form of angle, because angle is highly dependent over here. So lateral coherence, angle dependent. Now you see, to understand this experiment, okay, lateral coherence experiment, you are knowing this experiment very clearly, Young's double slit, right? And then you may have gone through several times in maybe in 11th or 12th, Young's double slit experiment, right? Attend किया है ना पहले, सुना है ना ये Young's
Yes,
double
sir.
slit?
Yes, sir.
Yes, so that particular coherence which you see over there will be lateral coherence. Okay, why we are saying lateral coherence or angle dependent thing? because now come to that. And remember one more thing, out of these two coherence, your hologram thing will working on this lateral coherence. Keep in mind, many times it is coming into the exam, okay, that hologram or hologram technique is working on which kind of coherence pattern. So it's a lateral coherence. Okay, so you see I have written over this point, holography is essentially an interference phenomena, and it is that illuminating wave possesses sufficient coherence. So yeah, आपका interfere, you see this coherence, it is clearly written sufficient spatial coherence or lateral coherence. So holography is mainly depending on this type of coherence rather than temporal. टेम्परल में आपका माइकलसन वाला केस था, बट होलोग्राफी जो केस है वो आपका लेटरल कोहेरेंस का एग्जांपल है. नाउ कम टू द नेक्स्ट. Here is the setup. I hope you people have gone through that, so I will not go in much detail, but you see source is there and you see the distance from here to here, here to here. Just 1 minute. It is equal. Okay, distance is d between these, so this aperture s1 s2, this is s is the source, this is the total distance capital D, and here the final outcome you will see, right? There are so many waves will come out like this, and similarly from here also, isn't it? And something you are getting like this. So that's how you have studied so many times, and final outcome you will see on this T photographic plate, और वो center पे आपका जो है वो dark spot, sorry bright spot आपको मिलेगा, यहाँ पे आपको image मिलेगा, and as soon as you move away from the center, the intensity will fade up, and this is obviously known phenomena, right? Now come to the case, suppose if instead of this source keeping at this moment, if I move to this point, now what will happen? This distance or the angle will not be uniform. Right now you see the angle, okay, it is almost, let's say 45 degree, here to here or here to here it's 45 for example, but the moment you consider this source over here, then you see the angle, it is almost flat, okay, and here it is, you see something different. Let me change the color here and here, this line as well as this line. Okay, so you see there is a change, or let me clear it out one more time. Now you see once again, you see this here the angle, and for this angle, okay, there is a mismatch, but in this case this was very clear, the same angle. So if you consider this as a source, then of course the output is not that much accurate which you get corresponding to this S. Okay, yes, of course it will shift to the other point. So that is what happening over here. Now come to the next. All such things I have given over here. What happens if I move it, or what will happen if I change it, something, everything is there. I will not go into detail because we have limited time, just 4 minutes. So let me complete this. Then you may get a formula. Now you people have written, or you people may have heard one more formula. Something like this, angle equal to arc over radius. पढ़ा है ये formula भी?
Yes.
Now in this type of coherence we are using this formula only, nothing else. Okay, so just go through that carefully. I am skipping it a little bit fast because we have limited time. Okay, so all such things are there, you can refer to that anytime. And now come to the important part. Here it is, this one. So this formula you have to compare with the same angle equal to arc over radius, and you can identify what is the quantity. Okay, and if you see carefully, this lambda by theta is having the unit of this d, यानी d का जो यूनिट होगा, ओके, या MLT फॉर्म जो होगा d का डायमेंशनल फॉर्म, वो lambda by theta का भी सेम होगा, because then only we can compare which is large, which is small, something. So lambda by theta is having the unit of distance. Okay, you see. So this distance, lambda by theta distance, we are knowing as lateral coherence width. Okay, so that is high. That means you see मैंने इसको lateral coherence width को LW से डिपेंड किया, denote किया, and it is equivalent with lambda by theta. Okay, now coming to the important part, maybe on the next slide. Okay, again I think this is only, okay, so you see this lateral coherence width, okay, it has to be always larger than this value of d. You go through earlier slides and what is this small d. If you remember, then small d is the distance between the apertures. Okay, let me show you one more time. Here it is. This D you see, right? This is the distance between these apertures. So you come to this lambda by theta factor. That means the coherence width has to be very, very large compared to D. Then only this type of coherence will happen, and then only you will see the hologram pattern. If this is not fulfilling, okay, if this factor is not, if this criteria is not fulfilling, then your lateral coherence will not happen. And if it is not happening, then you will not able to see the hologram picture. So it has to satisfy this always. Okay, that lateral coherence width has to be always very, very large compared to the value of D. D is the distance between the aperture which you have. Okay, so coming to the next, yes, all such things they have given, nothing to worry with that. Requirement of hologram. So I will come to this, just 1 minute. You see, I have highlighted the part, okay, requirement of hologram. So you see over here. In order to that, instead interference fringes we form in the hologram of the complete object you see to be recorded. Okay, complete object, since you need to record, then only you see the proper hologram part. Now, what is the criteria? The maximum path difference, okay, between the reference wave and the wave from object, that means the object wave, must be less than the coherence length. Now, the previous example you see, let me go to the previous slide. Here, okay, so in this coherence width, they have considered that it has to be very, very large from this D, but it is applicable in this Young slit experiment. Now the same principle, same logic, how you can apply to the hologram. So that's what we have done. This, here it is, just 1 minute. Yeah, here it is. So the maximum path difference between the reference wave and the wave of the object from the object, that means object wave, must be less than the coherence length. Are you getting that? This path difference we are denoting, let's say, with the small d. So small d has to be very, very less than this coherence length, just like in the earlier case which we have seen for the Young's double slit. So this is the requirement. If this is the case we are obtaining in the hologram, then only we are able to record it properly. Otherwise, if this criteria is not matching, you will not able to record anything.
Sir, what is the logic behind this? Like, why this only condition should satisfy? Why not the either one?
No, because it is the case of, see, it is the case of coherence, right? अगर आपका पार्ट डिफरेंस ज्यादा हो जाएगा तो क्या होगा, आपका इंटरफेरेंस होगा ही नहीं. So to get it interference, to make the interference constructively, this criteria has to fulfill. Okay, and that can be possible only in the case of this lateral coherence, because it all depends on the angle, arrival time. So if it is not matching, आपका interference हो ही नहीं पाएगा.